Three. Welcome to Chem 327. As you can tell, I've surrounded myself with bound copies of journals because today we're going to discuss papers, journals, and specifically your first activity for the course, which is about creating a critique of a paper. There are 5 papers that you can choose from. Choose the one that you like best. And we would like you to think critically about this paper, and we'll give you some pointers today. And on September 23 at 2 p.m., we will have a discussion in small groups of these papers based on what you have thought about them. Basically, we'd like you to look at the details of the paper and be able to think and ask yourself, think about what they've done, what could have been done better, and can it be extended to something else? So there are 2 main goals that we have. The first one is for you to get an exposure, to introduce you to peer-reviewed publications, and to introduce you to how to read papers critically. But more importantly, for the purposes of this course, we'd like to use this as an example on how project ideas can come about, starting with an existing work and how you move forward and ask questions so that you can come up with ideas for a project. Now, in the future, we'd like you to be able to have a habit of looking at papers critically, analyzing that, coming up with ideas, even as you read a paper. So let's get going. The papers we've chosen are listed in the Quarkus site, so go and choose which one you like best and sign up for the paper. There's a limit of 5 or 6 people per paper, so if you don't get your first choice, you have to go to your second choice. Anyway, first let's begin by discussing what a paper is. You've heard the term peer-reviewed publication or peer review, but do you know what's the actual process of getting something peer-reviewed? Well, let's go through it one by one. First of all, the authors of the paper are the people who did the actual work, and they also wrote the paper. There may be several authors. They don't all do the same amount of work. They don't all do the same thing. And then after the work's done and written, the paper's written, the paper's submitted to a journal. So the question is, which journal? Well, different journals are for different types of areas. And you can look up on their website what they're interested in publishing, but you can also tell by browsing through the journals. Like these journals behind me, you look through them and you can see what kind of papers are published in them. Of course, browsing is not as common these days. You basically use your computer to search for papers, because you don't just sit in the library anymore. But it is getting more confusing because there's a proliferation of journals now, in part because there's an explosion of work in the sciences. But in some cases, it's because there are journals that are pretty much a business. There is a charge when you publish in many journals, and you're already written the paper, you've done the work, and when you publish, you pay page charges, and then the journal goes around and sells it to the library, who also pay a lot of money to keep the journal in their shelves. So there is a business to journal publication. And in fact, there are journals that sometimes are referred to as predatory journals, which are primarily there to make money and care less about the quality of the work. So not all journals are the same, and you should think about that when you're publishing and even sometimes when you're reading papers. Now, there are journals whose policy is first and foremost that the paper be of general interest. And in this category, you've seen Science and Nature. So the editors, before they even peer review the paper, they make a quick decision as to whether the paper is of general enough interest to be in their journal. There are also other journals that will make a quick decision based on whether or not the submission is along the lines of the journal. But typically, once the paper is submitted, the journal sends it out for peer review. Typically, 2 or 3 experts in the field, sometimes more, who agree to review the paper. Now, doing a review of a paper is a volunteer work of scientists. We don't get paid to do that, right? The reviews are done, of course, therefore vary in quality. It depends on the time one is willing to spend on reviewing the paper. Now, with every year, the number of papers submitted keep increasing, and so there's actually less and less time for carrying out a peer review. So the peer review is not perfect. Many things slip through, but it's the best system we have at present. So it's still better not than just publishing anything that comes to your mind, because at least it means that it's undergone through the scrutiny of some experts. Now, the reviewers make comments, they raise questions, they sometimes make objections and suggestions, and they make recommendations whether the paper should be accepted, does it need revision, or should it be rejected. The editor then makes a decision based on the reviewer's comments, as well as considering the overall policy of the journal. So the editor may decide to send the paper back to the authors with the comments of the reviewers. Typically, they do not identify the reviewers, although recently there are some journals that ask the reviewers if they would like themselves to be identified. And the authors are given a chance to respond, typically, unless the paper is really rejected outright. Uh, so then it goes to the same to another iteration if the authors decide to respond, or sometimes the authors may just choose to publish it in a different journal. Now let's talk briefly about the typical parts of a paper. First, there has to be a title. That stands to reason. You got to know what the paper is about, and that title is reasonably important because that's the first thing that attracts people's attention. Then you list the authors and the affiliations of the author. Now, the order of appearance of authors on a paper depends on the field and on perhaps on tradition of the field. In areas like particle physics, for example, where there are dozens of authors, it's usually done alphabetically. In physical chemistry, the tradition is that the principal investigator or the project leader, the research director, comes in as the last author and usually gets an asterisk as the author to whom correspondence should be sent, which makes sense because the students may graduate, but the professor, the supervisor of the work, is the one who's still able to respond to queries years down the road. The first author is typically the person who has done the most work, usually the person who took ownership of the project. Now, sometimes you see an asterisk on two people, and it says contributed equally to the work. And that happens, and people want to give equivalent credit to both the number one and the number two authors. Now, after the authors come the abstract. Oops, what happened to my... There you go. The abstract is a short summary of the paper. It's an important part of the paper because it's the one that's seen generally. So if the paper is not open to the public, and if people don't have a subscription to the paper, they can still usually get the abstract. It's a short summary of the results. By tradition, one doesn't use the first person pronoun in the abstract. So the abstract is typically written in the passive voice. I don't know why, but that's how it generally works. Now, so comes the body of the paper. We start with an introduction or background. This should be concise unless there's a good reason to explain much more, but at the same time, it should be complete enough to indicate background information and position the paper in the context of that background information. In a good introduction will have all the material you need to actually understand why they're doing what they're doing. Now, the experimental section comes next, typically, and it describes the materials and the methods that one used. In some journals, they put the materials and methods at the end. So you have to look up when you're submitting to a journal, you have to understand what their format is. If you're writing a paper, this is probably the easiest to write because it's just factual, what you did, what you used. However, you have to have enough detail because the work has to be replicated based on what you said in the experimental. Hence, if you use chemicals and materials, you have to say what the sources are, the purity. Sometimes you have to say the lot number, depending on what kind of material we're talking about. The same with the instrument. It's typically needed who made it, what it is, what's the model number even, depending again on the instrument. Okay. After the experimental, you have the data and results. You want to present it concisely but completely. The same when you write your report, your final report for the course, you have to think about how to present your data. You do not present every single data you take in one after the other. No, you have to think about it so that you can gather them together in a way that makes sense to the reader. You have to make a decision. Should you put a graph? Should you have a table? Should there be a figure? You don't want uh, to have replicates like something you've had in a table is also in a figure. Well, that may be a waste of space. And so it requires some thought about how to organize the data. The goal here is to make sure the reader can understand the point that you are trying to make. And so before you write the data and results, you should organize your thoughts and present them in a way that makes sense. A typical mistake is people would present their data chronologically, and because that's how they did the experiments, but it can be very confusing to the reader if after four steps you found that what makes sense is to do things differently. So you have to think carefully about presenting a data and results. And when you're reading a paper, you likewise look at how they actually presented their data and results, and are you convinced that their data in fact cover everything that they said they were going to do, and does it make sense, the number of trials they did, the spacing between the different data points, and so on. After the data comes the discussion, which may be the hardest to write depending on the paper. It's the analysis of the data, but perhaps it's done in the context of a theory. Are you trying to test a theory? Are you trying to fit the data to some theory, or perhaps in the context of other work in the area? It's where unexpected results may need to be explained. Maybe are they errors? Are they potential errors? Or perhaps they're very exciting because they're unpredicted. Um, some explanation may be simply speculation at this point. I must say, my personal preference is that papers should not mix up results and speculations, because you'd like to have the results stand the test of time, whereas speculations, there may be more than one way of interpreting the same data. I recommend strongly that when you read a paper, you think hard whether or not you agree with the discussion and conclusions that they arrive at based on the data that they had taken. Because really, sometimes, in many cases, in fact, there may be more than one possible explanation that would fit the data. And if you think about that possible explanation, maybe you have to think then, how would I test whether they are right or whether I am right? Papers need to be wrapped up in the end with a summary and conclusion, and sometimes put in more speculations at the end. Again, as I said, I would just ask is that people clarify which one is factual versus which part is a speculation. Now that you know the parts of the paper, what do we expect you to do for this activity? As I said earlier, I expect you to choose one among the 5 papers that are posted on the course site. Sign up for your choice, and if you don't get the first choice, well, sorry, but we want to limit the number of people per group. So you have to read it critically. There are 2 types of issues that you can examine. But let's pretend you're the peer reviewer. You're really doing a review of the paper, and you can look for issues that are substantial or trivial, right? Now, of course, it would, you'd say, why would I look at anything that's trivial? Maybe it's only the substantial ones that are important. And you're right, if there's something major that's a problem with the paper, then the others don't matter because there's already something wrong in the big picture. But if the paper looks good, then the trivial parts may actually be very important, because it may be that did they miss some important control that looked trivial at the beginning? Did they have enough data? But also, if the trivial issues are not taken care of properly, they can really diminish the importance of your work. So, for example, if you don't present the data very well, then it can be very confusing and the reader may be lost as to the significance of the work. So when you look at a paper, you look at the tables and the figures, and you try to understand, what are they telling me? What are these figures and tables leading to? Does it make sense? Are they consistent with what the authors are claiming? Okay, so you look at all the details like so, and pretend you're a peer reviewer and you can understand, is this a good paper? Will I say okay and allow it to be published? Of course it's already published, but not everything that's published is great. Okay. But the other thing that we really want you to do in this course is to use this activity as an opportunity to come up with ideas. Because you are the patient reader, you want to understand what's the goal of the paper, what they're really trying to do, why are they doing it, and then you come up with many questions. Why did they choose to do that kind of approach? Why did they choose those materials, for example? Is there a better thing to have tested? Is there a parameter that they did not measure? You look at the data. Are they good enough to be able to conclude something? Would a different approach give better information? Are they missing some aspects? So basically, can you think of what else could they have done? Um, and maybe then ask yourself, why do you think they didn't do that? Would it therefore make sense for you to do that missing thing that they didn't do? What do you think of their explanations? Do you agree? Because if you disagree, how would you actually test whether you're correct or they're correct? And is there another explanation for their observations? Is there an improvement on the experiment? Or maybe the experiment is great and you're just asking, well, is there an extension of the work? This is so exciting. If I want to get in this kind of work, what are the next steps that I could do? Take a look at their conclusions, see if you agree. And if not, how would you have written it? What would you like to conclude? And what would you need to do in order to reach that conclusion? Okay, so the idea is that the paper that you chose should have given you much food for thought. And, I hope that when you read papers in the future, you get in the habit of questioning and critical thinking. But in the meantime, for this course, what we'd like you is to be able to analyze and do the next step, which is to come up with potential extensions of the work. Now, you probably will not do it during this course, but this is our first exercise in coming up with ideas. So during the class on September 23, come ready to discuss the paper. We will do that online in small groups. Okay, see you then. Goodbye.